Welcome to Study Loop.
This is the answer to Chapter 21, problem number 66 from the Smith Organic Chemistry textbook. And this problem asks us to make two molecules starting from only ethanol and then using whatever reagents we need. This problem also, for some reason, gives us our targets in really weird notation that to me is very difficult to look at. So I went ahead and redrew the target for A here. And once you do that, it becomes much more readily apparent, at least in my opinion, that this is an acetal that we're making here in A. So we need to start from ethanol. We need to construct this 4-carbon backbone, and then we need to make this acetal. So to me, we're going to make 2-butanone and then treat it with tosic acid and ethanol. And I think that that's the way to go. And so we're going to have to make this in pieces. So I'll start over here to the right of the molecule. So of course we have to start from ethanol as the problem stipulates. And to make one of our pieces that's going to be suitable for a reaction, we'll just take ethanol and we'll treat it with PCC. And so now we have this aldehyde here, acetaldehyde. And so to me, this is the way to make this, right? So we're gonna use this piece that we just made, and we're gonna take another molecule of ethanol and convert it into an ethyl Grignard reagent, and then we'll react our ethyl Grignard with this acetaldehyde that we made. We'll oxidize that product up, and then we'll have our 2-butanone, and we can just make the acetal. And so that's the way I see this synthesis going. There are certainly probably other ways to do it that fit, starting from just ethanol, but that to me is by far the most readily apparent. And so to do that, we'll take this other molecule of ethanol, as I said, we'll treat it with PBr3 to get to the bromide. Once we have the bromide, treatment with magnesium and ether. Although I think the textbook omits the ether most of the time, whatever, is going to get us to our ethyl Grignard. And then, so once we have our ethyl Grignard, we will use this molecule that we made up here, acetaldehyde, and then water workup. And so now we have our 4-carbon chain established. We have an alcohol here at carbon 2. So treat that with some PCC. Now we have our 2-butanone. And then all that we need to do now is make the acetal here. And so the way to do that is ethanol, since we want the ethoxides, and then some tosic acid. And that is going to get us to our product for A. So again, I think drawing it, that's ugly. Drawing it out in line notation rather than leaving it in the weird like letter notation, I think makes a big difference. I think it makes it a lot easier to see what's actually going on here. Yeah. Okay. Yeah. So as I said, that is our desired product for A. There it is. So then B, we'll put on its own page here. So B, so again, our product, I'm going to redraw it in a way that I think is easier to look at. So we have a terminal alkyne, And then we have an acetal made from ethylene glycol. Okay, so there's our target for B. And again, we can only start from ethanol. So we're going to have to make two pieces here. So we need to make our ethylene glycol. So let's go ahead and do that first. So ethanol, if we treat it with some concentrated sulfuric acid, is going to dehydrate to ethene. Ethene we could treat with osmium tetroxide and then sodium hyposulfate to do a dihydroxylation. So OSO4 followed by NaHSO3 and a little bit of water. And so that is going to get us to ethylene glycol. And we'll leave the ethylene glycol alone for now. We'll come back to it. We'll need it at the end. So again, the way that I see this going is to assemble the carbon backbone that we need to make the ketone that we need, and then treat the ketone that we make with this ethylene glycol and tosic acid, and that's going to get us to our acetyl protected ketone, or to just our acetal. Okay, so again, we have to start from ethanol and only ethanol. Again, we'll start by dehydrating it to ethene. We can do a dibromination here. And then use two equivalents of sodium amide. So 2 EQs. Sodium amide. Oops, should be a 2. Apologies. NaNH2. So that's actually going to get us to the alkyne. So what is that? Ethylene. And then, oh boy, this is this is a throwback to a much earlier chapter. And so if we treat that alkyne with sodium hydride, it's going to deprotonate. So I'll actually switch to drawing it this way just for a moment. So it's going to deprotonate one of those carbons in the alkyne. And so now that carbon can act as a nucleophile. And so from problem A, we made acetaldehyde. And so rather than showing how we made it again, we can just use it since we've already made it. So if we use the alkyne that we made and then deprotonated to do a nucleophilic attack on the acetaldehyde that we made in part A, we will end up with this. And so obviously here we are pretty close to where we want to be. And all that remains is to oxidize this. So oxidation is going to take us up to the ketone. Oops, I should probably probably list a reagent. So we'll oxidize it with PCC. That takes us to the ketone, as I said. So now we can use that ethylene glycol that we made in the beginning of part B here. So ethylene glycol, tosic acid, and that is going to get us to our final product. Okay, and so there it is. And so I think a big part of solving this particular question is to redraw these molecules in a way that is easier to look at. And then once you can see that they're both acetals, just remember how acetals are made. And then from there, you can see that you're going to have to construct a ketone and then do an acetal formation. And since we have 4 carbon backbones, but we're only allowed to start from 2 carbon molecules, we just need to remember different strategies that we have for making new carbon-carbon bonds. And so that's the answer to chapter 21, problem number 66.